Welcome back to another explainer. Today, we're tackling something that's literally hidden right behind our walls, but man, it carries incredibly high stakes. We're talking about waterproofing. We're going to look at the fascinating evolution of how we protect our buildings from their absolute greatest natural enemy, water.
Okay, let's dive right into this, because this stat is wild. Waterproofing only accounts for about 1% of a building's overall construction cost. Just 1%. But when it's ignored or just done poorly, it can be responsible for almost 90% of the structural damage a building sustains over its lifetime. I mean, that is a staggering risk-to-reward ratio.
So here's our roadmap for today. We'll start with the 1% rule, then look at the concrete problem. After that, we're climbing the ladder of solutions: rigid cementitious protection, bituminous solutions, high-stretch liquid membranes, and finally, the premium option, polyurethane.
All right, first up, the 1% rule. When you skip out on that tiny 1% budget item, water seepage actively goes to work destroying the core of your building. Moisture sneaks in and literally causes the internal metal reinforcements to rust. You know, this isn't just about some ugly damp patch on your ceiling. We are talking about water completely ruining the structural integrity of your home. It turns a minor, annoying leak into a catastrophic structural failure over time.
Which brings us to part 2, the concrete problem. You hear this question all the time, right? Hey, if I've poured my concrete perfectly and it's rock solid, why do I even need waterproofing? And honestly, it's a completely logical question, but it relies on a major misunderstanding of how building materials actually behave in the real world. See, you have to think of concrete less like a solid rock and more like a giant, really dense sponge. Even the absolute best concrete isn't watertight unless its microscopic pores are actively sealed off. Plus, your building breathes. It's constantly undergoing thermal expansion, it flexes, it cracks, and all of that leaves it wide open to water intrusion.
Historically, we tried to fix this with old-school, rigid methods. Think brickbat coba or thin exterior paints. But they easily succumb to wind-lashing rains. The problem? They are totally inelastic. So when the building expands, boom, they crack. Not to mention, they rely on unskilled labor and add this massive, unnecessary dead weight to the structure with things like marble or China mosaic. Modern methods, on the other hand, are specifically designed to be elastic, lightweight, and actually adapt to the building's movement.
So, let's look at modern solutions. Section 3, rigid protection, specifically cementitious.
Now, what's really interesting here is the chemistry. This stuff comes as a powder containing sand, silica, and active chemicals. When you mix it with lime, it triggers this hydration reaction that creates a rock-solid waterproof seal, just about 1 to 2 millimeters thick. Professionals use this over concrete structures like foundations and sidewalks.
But there is a catch. It's super easy to apply, sure, but it is incredibly rigid. Because cement inherently lacks flexibility, it just can't expand and contract. If the concrete underneath cracks, that seal is going to crack right along with it. Because of that, it absolutely cannot be exposed to sunlight, weathering, heavy traffic, or chemicals. It belongs strictly indoors in wet areas. We're talking toilets, kitchens, basements, or in rigid water-retaining structures like concrete tanks and treatment tunnels.
Moving up the flexibility ladder, Section 4, bituminous solutions.
So, bitumen basically gives us 2 main paths. First, you've got liquid bituminous coatings. These are fantastic for ground moisture, like around foundations, but they can be pretty brittle under UV light unless they're heavily modified with polymers. Alternatively, you have bituminous membranes. These are heavy-duty, 2 to 4 millimeter thick sheets that come in massive rolls. You either torch them on with a flame to melt the bond, or you use self-adhesive types. And the real magic here? They have a massive 150% elongation rate to stretch and seal over active cracks.
But listen, that 150% stretch isn't entirely bulletproof. Since it's black and bitumen-based, it heavily softens under the brutal summer heat. It also has a limited lifespan because the solvents continuously evaporate, and crucially, you can't just leave a membrane exposed. You absolutely have to cover it with a layer of screed concrete to prevent anyone from accidentally puncturing it. Still, for retaining walls, basements, and flat roofs, it is incredibly effective.
Next up, Section 5, high-stretch liquid membranes.
And this brilliantly illustrates a massive leap in technology. We started with cementitious at virtually 0% stretch, right? Then bituminous got us to 150%. But liquid waterproofing membranes, they absolutely shatter the curve, stretching up to an incredible 280%. They are fully capable of extending and snapping back to their original shape without taking any damage whatsoever.
Because it goes on as a liquid, usually a primer coat plus 2 top coats applied with a trowel, spray, or roller, it cures into this completely joint-free, rubbery coating. It's often reinforced with glass-reinforced plastic for extra tensile strength. And get this, in refurbishment situations, applying this system is estimated to be 70% less expensive than a total roof replacement, and it can last up to 25 years. Quick warning though, the application requires exact precision. If that coating goes on too thin, the membrane will simply tear.
Finally, Section 6, the ultimate final boss of waterproofing,
The premium option, polyurethane.
Polyurethane is this highly advanced, complex, two-part chemical system. Step 1 is polyol, your base component. Step 2 is isononide, which is the reactor. When you combine them in a very specific design ratio, they create an incredibly deep penetrating liquid coating. What's actually super fascinating here is that, unlike laying down heavy sheet membranes, this requires comparatively less skill and supervision to apply. The installation is incredibly fast, and it leaves a perfectly seamless finish.
Once this stuff cures, it is virtually invulnerable. I mean, it is highly resistant to UV rays, extreme weather, oils, detergents, you name it. It boasts insanely high flexibility and wear resistance. That makes it the absolute perfect heavy-duty solution for high-traffic areas like pedestrian decks, bridge decks, and massive parking garages, easily giving you a 25-year working life.
So, the crucial point here is that preparation is literally everything. Polyurethane is incredibly sensitive to moisture. Before a single drop of this premium material is applied, the moisture content of the underlying concrete slab has to be strictly evaluated. If that concrete is too damp, the polyurethane just won't adhere properly, and you're going to experience some devastating peeling and debonding down the line. Now, we have to be objective here and talk about the drawbacks, because this isn't just some magic cure-all. First off, it is the most expensive waterproofing method on the market today, period. Second, the chemicals involved are highly toxic. If the raw material touches your skin or if it's inhaled, there are serious short and long-term adverse health effects. This is absolutely not a weekend DIY project. It 100% mandates professional handling.
And that brings us full circle right back to where we started. We've seen how simple rigid powders and highly advanced, stretchable chemical polymers can protect a building. The engineering is honestly incredible. But the real takeaway? It's the math. Knowing how water actively degrades metal and concrete, I'll leave you with this one thought. Is saving that 1% on your construction budget really worth risking 90% of your structure? I'm pretty sure you know the answer. Thank you so much for exploring this fascinating topic with me today. Keep asking great questions, and I'll see you on the next Explainer.